So important trig theory you should know. The first thing I want to do is I want to basically what I'm getting to is that derivative of sine is cosine. We're going to see how this works. But before we do that, let's just assume it's true. Okay, we're going to assume this is true. Okay, and then we're going to also assume that the derivative of cosine is negative sine. So we're going to start out with those two. We're going to say, okay, this is true, and we're going to derive those in a minute. But I want to show you first how you can use those for tangent. So if you have tangent of x and you want to find its derivative, that's the same thing as the sine of x over cosine of x. You want to find its derivative. So this is the quotient rule. So this is f over g prime, which basically we're going to use that. So it's f prime g minus f g prime over g squared. So here we go. So we're going to go, the sine is the f and the cosine is the g. So f prime g, so derivative sine is cosine times the bottom, that's g, minus the top sine times the derivative of the bottom. The derivative of the bottom is negative sine of x. Derivative of cosine is negative sine over the denominator squared. So if you look, this negative and this negative, they combine to make this a positive, so that's gone. And so you have cosine squared plus sine squared. Essentially, you have cosine squared of x plus now sine squared of x over cosine squared of x. Now you can, the numerator is 1, cosine squared plus sine squared is 1, and now this is over cosine squared of x. And so you get secant squared of x. So the derivative of tangent is secant squared, and that's how you get it. If you forget this on a test, just derive it. Just make the tangent sine over cosine, use the quotient rule for it, and then you're done. You got it. You just work all throughout. Now, let's do secant. So suppose on a test you forget secant. So you want to find the derivative of secant of x. Well, secant is also known as 1 over cosine of x. So you take the derivative. So that would be, we're going to use f over g prime, right? Because it's the top is f and the bottom is g. So that's f prime g minus f g prime over g squared. So here we go. The derivative of the top is 1. So the derivative of 1 is 0 times the bottom, which is cosine x, minus the top times the derivative of the bottom, which is negative sine of x, over the bottom squared, the denominator squared. So that's just from here, right? So 0 times cosine is 0, so this is all 0. Negative 1 times negative sine x is positive sine of x over cosine squared of x. So essentially, this is just sine x over cosine squared of x. All right, so now you can make this sine x over cosine x times 1 over cosine x, which just gives us tangent x times secant x. And that turns out to be the derivative of secant of x. So secant x, the derivative, is tangent x secant x, or secant x tangent x, sometimes they're right. So once again, if you forget this on a test and you need to find the derivative of secant, then you can just derive it, all right? So let's do one more. There's one I don't know why I always never remember this one, cosecant of x. So we'll take the derivative of this. So this is 1 over sine of x. And so you take the derivative, you're going to use this f prime g minus f g prime over g squared, and you get your answer out from there. I'll let you do this. You do this. All right. Okay, so now let's talk about where the derivative of sine is cosine. Like, so where does that come from? So the derivative of sine x is cosine x. So y. All right, so the derivative, remember, is the limit as h goes to 0. I can write it better than that. Limit as h goes to 0 of f of x plus h minus f of x all divided by h So we're going to do that with sine of x, limit as h goes to 0 of sine of x plus h minus sine of x all over h, which is equal to limit as h goes to 0 of sine of x plus h. So what we're going to do is we're going to use this rule which says sine of a plus b is sine of a cosine of b plus sine of b cosine of a. This comes from trig, and it's one of those that you probably should memorize. So I'm going to use that right here. All right, so we're going to say this is going to be sine of x cosine of h plus, plus sine of h cosine of x minus the sine of x. The minus sine of x comes from this piece right there. So then this is all over h. All right, so now we're going to take this and let's analyze this. If you notice, there's a sine x in this and there's a sine x here. So I'm going to take those two together and I'm going to factor out a sine x. So limit as h goes to 0 of sine x times cosine h minus 1 is what you get out of that, and then plus sine h cosine x all over h. So now this is limit as h goes to 0 of, all right, so I'm going to split these two up. So it's plus in the middle here, so I'm going to split this up into two different limits. So this is sine x and then cosine h minus 1 over h, and then plus limit as h goes to 0 of sine h cosine x all over h. Now, this limit is in terms of h, right? So the limit is in terms of h. So anywhere you see an x, that function can be factored out. So that's exactly what I'm going to do, because the x doesn't rely on h. So sine x, and then we have limit as h goes to 0 of, and then now this is cosine h minus 1 over h plus, and now cosine x, limit as h goes to 0 of sine h over h. All right, so here's the hard part. If you look at these two limits right here, this limit here and this limit here, if you look as h goes to 0, they both go to 0 over 0, because cosine of 0 is 1, 1 minus 1 is 0, and then as h goes to 0, the denominator goes to 0. So we get 0 over 0 and 0 over 0. And these, we don't know what that is. So there's a long geometrical argument for figuring out what these are. I may do this in another video if you want. Look in the book. But it turns out that the limit as h goes to 0 of cosine of h minus 1 over 1, when you do some geometry, there's another way to do it using what's called L'Hopital's rule, but that's not until like chapter 4. The geometrical argument shows that this is actually equal to 0. And the geometrical argument also shows that this limit as h goes to 0 of sine h over h, this is equal to 1. So this one here, this is just 1, and then this one here, this is equal to 0. So what we have, I know this is a lot of mess here, what we have is sine of x times 0 plus cosine of x times 1. That all comes from this right there. Well, sine x times 0 is 0, and cosine of x times 1 is 1, so that's cosine of x. And so that is the, what is this? Well, we started out way up top here. It was going to be the derivative of sine of x. So the derivative of sine x is, well, the book likes to write it like this in Leibniz notation. Derivative of sine x is cosine x, and there you go. So that's the proof of that.